In this question, we are going to find the volume of the solid generated by revolving the cardioid r equal to a 1 minus cos theta about the initial line. So it means we are rotating about the x-axis. So it's if we have a cardioid of this form, then the limit will be pi to 0. But if we have a cardioid r equal to a 1 plus cos theta, then the limit will be pi 0 to pi. Okay. Be careful with this. When you have the cardioid of this form, the limit is pi to 0. And if you have a cardioid r equal to a 1 plus cos theta, the limit will be 0 to pi. So here, whenever you take a polar form, we have x equal to r cos theta and y equal to r sin theta. So you put this r cos theta here, okay, r value you put, and you multiply, then you find differentiation of this. So a differentiation of cos theta is minus sin theta. Differentiation of cos squared theta is 2 cos theta, and differentiation of cos theta is minus sin theta d theta. So we get here, so minus minus we get plus, so we get minus sin theta plus 2 cos theta sin theta d theta. Y is what? R sin theta. You put that value. So if you multiply, you get this much. Or you can put this value also. So volume is given by pi to 0, pi y squared dx. Pi is constant. We put the value of y. So y is this. So you put here a 1 minus cos theta sin theta whole thing square. And here we have a. Now dx, we have this. So you let us put this value here. So we are putting this value here. So from here we can take sine common. So we get a sin theta 2 cos theta minus 1 d theta. So here we are getting a square into a, we get a cube, that will come out. And we are having pi to 0, 1 minus cos theta whole thing square. Sin squared theta value, sin squared theta can be written as 1 minus cos squared theta. So we have 1 minus cos squared theta, 2 cos theta minus 1, sin theta d theta. So now let us take cos theta as z. So I'm taking z equal to cos theta. If I differentiate this with respect to theta, I get minus sin theta d theta. So dz minus dz is nothing but it is equal to sin theta d theta. We have to change the limit. So when theta is pi, you put here pi, we get minus 1. So z is minus 1. When theta is 0, you put here 0, we get 1. Z is 1. So the limit changes from minus 1 to 1. So we have here minus 1 to 1. 1 minus z whole thing square, 1 minus z square, 2z minus 1. In place of my sin theta d theta, you put as minus dz. So we have here minus dz. So this minus you take out. So you get minus pi a cube, and the limit changes from minus 1 to 1. 1 minus z whole thing square, 1 minus z square, 2z minus 1 dz. You multiply these two, so we get this. You split with the formula a minus b whole thing square. So we get this. Then you multiply these two. After multiplying, you get cancel and you get simplify of this form. After that, you try to integrate this. So if you integrate z, we get z squared by 2. Integration of 1 will be z. Integration of z cube will be z4 by 4. Integration of z squared will be z cube by 3. Integration of z4 will be z to the power 5 by 5. The integration of z to the power 5 will be z6 by 6. Z to the power 6 by 6, and the limit is from minus 1 to 1. You put the upper limit, then give minus sign and put the lower limit. Okay, so we put the upper limit, we give minus sign and put the lower limit. After that, you try to simplify this and you get here minus 16 by 6. You cancel this 2 by 2, 2 is 16, 2 3 is 6. So we get minus 8 by 3. So minus minus we get plus, so we get 8 by 3 pi a cube. So that is the volume of revolution of the cardioid r equal to a 1 minus cos theta. So here I'm giving you as an homework r equal to a 1 plus cos theta. So here only you do the same as what we have done, but only you change the limit from 0 to pi. Thank you.